Hi everyone, this class is a math call. This lesson is the binomial theorem. Um, this topic will talk about the binomial theorem. Binomial mean by mean two, correct? So the binomial is a polynomial that has two terms. For example, x plus y. This is a two term, so it's a binomial. So if we say this one power 0, this one equal to 1, right? So if we have x plus y, if we write along this one mean it's a power 1, correct? And then if I have power 2 and then power 3 and power 4, so on. So like a power 2, you can use the formula, right? Become x squared plus 2xy plus y squared. Okay. So then in this, if this one keep going, for example, we have the higher power. Okay. If we have the binomial help, this section binomial help us about help us for study. We're gonna study the formula of the binomial theorem to help us to expand when the power become very large or high number. For example, if we have xy plus power 50 like this, how you gonna expand and get for how many terms inside? Like a power 2, we have 3 terms, right? 1, 2, 3. We can see by the plus side, break it down, become three terms. 1, 2, 3. Then if 50, power 50, this gonna be, power 50 gonna be 51 term. Gonna have 51 terms. But when you expand, it's quite hard, right? But in general, everyone will remember only up to power 2, power 3 maximum, or power 4. Okay. So, but when higher than the index here, the power become higher. It's very hard to do unless use a computer, right? But in this case, this theorem, binomial theorem, can help us to expand and get all the terms. Okay. And then before we can, and then we're gonna use the formula how to expand it. But before that, before we're gonna do go to learn the binomial theorem, the expansion for each question, for some question, we gonna we should know about the binomial coefficients. Binomial coefficients. See this? I write down here. See if binomial, sorry, binomial coefficients. What is a binomial coefficient? You see, coefficients we know, right? For example, like this one, coefficient of x squared is what? Is 1, right? And coefficient of xy is 2 plus 2, and coefficient of y squared is 1. Okay, so before last lesson, we learned a combination. Remember the combination formula NCR, correct? The formula NCR, in fact, over n minus r factorial times r factorial. Okay, so actually NCR in the lesson of the binomial, this one represent coefficients. Actually, this one in the algebra here, in this topic, binomial coefficient, NCR mean the binomial coefficient. For example, NCR, we can use NCR formula to get the value of 2, how to do, right? But before that, we come back to see the Pascal triangle first. Pascal triangle. Okay. maybe we come back to see the example for binomial coefficient. For example, question A, want to, for the example, say, find each binomial coefficients. Okay, for example A, if we like 8C2 like this, right? So same thing, if we like this one, it's the same meaning. Or sometimes we can like in this way, 8-2. Okay, so this one, if you use calculation, use the formula of combination here, you will get the answer correct, or you use calculator right away. Like in this case, this gonna be what? Use the formula here, right? So equal to 8 factorial, 8 minus 2 factorial, and time 2 factorial. So equal to 8 factorial over 6 factorial times 2 factorial. So then you simplify, or you can use calculators, okay? So become 8 times 7 times 6 factorial over 6 factorial times 2 factorial. So 6 factorial cancel, 2 factorial mean 2 times 1. So 2 this simplify, this one become 8. So equal to 28. So this is a coefficient of what? Coefficient of 8 represent the eighth law, and 2 represent the second term. The second term, okay? 8 and 8 mean the eighth law, and 2 represent the second term. So what then does on this term, second term, the coefficient equal to 28. What this about? Then we can see. We go next for see the Pascal triangle, and then you will more understand what is the meaning SC2, why 8 is the eighth law and 2 is the second term. Okay, now we go see the Pascal triangle first. Okay, go to see the Pascal triangle. Now go next one. Pascal triangle. See if, for example, we're gonna use Pascal triangle to find the binomial coefficients. Okay, we come back to the beginning. I give you, say, for example, I have x plus y power 0, right? Because it's a binomial, right? Because we have two terms, and power, the index equal power 0. So this one gonna be equal to 1, right? This one equal to 1. I will write down here because I want to write a triangle. So now x here, if x plus y power 1. So this one, power 1 still equal to x plus y, correct? So we write down here, become x plus y. Okay, and next one is power 2, x plus y, power 2. So this one gonna be x squared, correct? X squared plus 2xy. That's a formula you learned before, and plus y squared. Now we go on, if we have x plus y power 3. So we're gonna have this one gonna be what? Gonna be x power 3. The formula is what? X power 3 plus 3x squared y, right? Plus 3xy squared plus y cubed. And then next, if x plus y power 4 now, most of us, we don't know this one unless you have to break it down, become x plus y power 2 times x plus y power 2, and then you use the formula and time again. So take a long time to do, correct? So like a x, right? X plus y power 4. If you don't know how to expand, you have to break it down in this way, correct? Become x plus y power 2 times x plus y power 2. And then you expand it, become x squared plus 2xy plus y squared, right? And this term is same thing. Time become x squared plus 2xy plus y squared. And then you have to time this again, one at a time. Time is one at a time, one at a time like this. So take a long time. So now we're gonna use Pascal triangle. But once you know this one, next we use formula, gonna be much easier. But now we see the idea how they get it first, okay? So now I'm gonna elect this part. Huh? Okay. So undo. Next one. So from when x plus y, the whole thing power 4, right? How we gonna get each term and the coefficients also? Like this one, x plus y power 3. You know the coefficient is at 1. Coefficient of this term x squared y is 3. Coefficient of xy squared 3 and y cube is 1. So then you can see if we like use the x plus y power 4, the next, the first term here should be x power 4, right? And the last term here should be y power 4, correct? Because this x power 4 and y power 4 is 4. Then you can observe this one, plus x power 4, so you line in order index. X power 4 next should be x power 3, decreasing down. So y become 1. And next plus x power 3, and next gonna be x power 2 and y power 1, this y gonna be power 2. And plus x power 2 already, right? Next should be x power 1. And y power 1, 2, and this one should be power 3. And then plus y power 4. So you observe power 4 gonna have 5 terms. 1, 2, 3, 4, 5. And you see the index. X power 4, x power 3, x power 2, x power 1. Y power 4, y power 3, y power 2, y power 1. Now, right now, the problem is how we get the coefficient in front of each term here. But this one we know right away is a 1, correct? Coefficient of x power 4 is 1. But then y power 4 is 1 for sure. But then in the middle term, inside terms, 3 terms inside here between, how we get coefficient for this x power 3y and x power 2y, the coefficient what's going to be. So then it's hard, right? Like I just elect the one. You have to expand, take a long time. So in this case, we're gonna use the Pascal triangle to help how to do. From here, you observe from this one, right? This one we call this one is a zero law. Start with 0. And this one we call the first law. And this one second law. And this one third law. So you see the index 1 and first law, power 2 second law, power 3 third law, and power 4 fourth law. Okay, first law. Now from this one we're gonna get only the coefficients of each law, of each term, to write it down in like a triangle shape. So we start from here 1, right? So I write it down here. I started here, so I like 1, right? First here 1, first law. Maybe I like in the same line. This one is a 1. And this one you can see the first law, right? This is a 0 law. First law coefficients are 1. Coefficients are 1 here, right? 1x plus 1y. So you like 1 here. The second law you like 1. And the second, that means the first law. And now second law, you see a coefficient of this is a 1, right? 1x squared. And this one's a 2. This one's a 1y squared. So at the same line, you like here 1, this is a 1x, and this is a 2, correct? So you lay down here on the same line. And this one's a 1, coefficient is a 1, so you lay 1 here. Okay, this is number 2, okay? This one number 2, okay? And then you see the third law here, get coefficient also. This coefficient of x power 3 is 1. So you like the same line here, 1. And next one is coefficient is 3, so you like 3 here. And next one here, coefficient is 3, right? So you like 3 here. Like in the triangle shape. And coefficient of y power 3 here is 1, so you like 1 here. Now you observe, but we don't have coefficient of the fourth law, right? So you observe from the triangle, the Pascal triangle here. One, we start from 1, from the 0 law, and the first law 1, 1, okay? And then from 1 here, you like the next, the first term here become 1. And then 1 plus 1 become 2 here. And this one number alone, so bring it down here. Now the third term, the first one always bring it down 1 here. And then 1 plus 2 become 3 here, lay down. 2 plus 1 equal to 3 here. And 1, pull it down here. Okay, from this coefficient of this, the above law, we can get the fourth law, correct? So we can see the fourth law, right? You always get 1 to here, bring it up front. And then 1 plus 3 here become 4. 3 plus 3 become 6. 3 plus 1 become 4. And 1 bring it down. Okay, so now we get from here, you can see we can get coefficient for the fourth law now. So I can insert here, right? So this 1, it means here it's already 1 here, correct? We have 1 here. And 4 mean the font in front of here. And 6 mean in front of the third term here. So you write out 6. And 4's gonna be here. 1 gonna be here. Okay, but 1 in front, usually algebra, we don't need to write, we leave it that without like number 1 down. Okay, so now from this, we can go on. If I find for the fifth law, right? So I'm gonna have x plus y power 5. Then I have this one. First gonna be x power 5. Do the same way, okay? Keep doing. This one gonna be x power 4, y power 1. And next plus x, need more space here. Come x power 3, y power 2. And next gonna be x power 2, y power 3. And next gonna be x, y power 4, and plus y power 5. So observe again, right? See, x power 5, 4, 3, 2, 1. X power 5, y power 5, y power 4, y power 3, y power 2, y power 1. So in the order, increasing and decreasing for x increasing and y decreasing. Okay, from this one, we we can get coefficient for each term right away. This one is a 1 for sure. In form of x fifth and y power 5 here, same thing should be 1. But we have to find the rest of term by use triangle, Pascal triangle here. So again, from the fifth row here, right? You can bring 1 down here again, bring number 1 down. Y always 1, I will explain you in the front here, y always 1. I will give you later by use a combination. So then next term gonna be 1 plus 4 become 5, you write down here. And then 4 plus 6 gonna be 10 here. 6 plus 4 become 10. 4 plus 1 become 5. 1 bring it down. Okay? So now we get coefficient of the fifth row now. So you can fill in, right? You can fill in here. 1 is mean, this one means here. And 5 in front of the second term here. 10 gonna be in the front here. 10. And this 10 gonna be in front of this one. And 5 gonna be this term, coefficient of this term. 1 gonna be there. Okay. Okay. So now in this case, you can. How about we keep? We can keep doing, right? Now from this, Pascal triangle, you can find this is a fifth term already, correct? This is a fifth term already. Now, if you want to find the sixth term, right? Everyone know how to do now, right? Gonna be x plus y power 6, right? So then if we want to get only coefficient now, because you know how to rearrange the unknown variable x, y already, right, in order. So if we get only coefficients, you use this triangle. So the sixth row gonna be 1, bring it down. And 1 plus 5 becomes 6. 5 plus 10 become 15. 10 plus 10 become 20. 10 plus 5 become 15. 5 plus 1 becomes 6. 1 and bring it down. Now this is 6, right? And now you go 7. 7x plus y power 7. Okay, this is 7 low, okay? We mean 7 low. So then this gonna be 7 low gonna be bring down 1 again. 1, 6 becomes 7. And this one 6 plus 15 gonna be 21. 15 plus 20 become 35, right? And this one 20 plus 15 gonna be 35 also. And 15 plus 6 gonna be 21. 6 plus 1 gonna be 7. And number 1 bring it down. Okay, so we do one more, so can refer to the example I just give you. Now F low gonna be x plus y power h. Okay, so we get only coefficient, bring it down, become 1. 1 plus 7 become 8. 7 plus 21 gonna be 28, correct? 21 plus 35 gonna be what? 6 and 5, right? 56. And 35 plus 35 gonna be 60, become 70. And 35 plus 21 gonna be 56, right? Yeah, 56. And then 21 plus 7 gonna be 28. And 7 plus 1 gonna be 8. And then bring 1 down. Now we work, and then you keep doing. Okay, this only have some fun, but you see, I try to work up to 8th row because remember the previous previous example I give you, find the binomial coefficients of, if I like this one, H C2, right? Remember the example we just finished? So H, in general, we say represent n, right, in the combination formula, and R2 is R, correct? So in this case, you can see this one mean binomial coefficients. So H mean the H low, okay, H low. So you count from the first row, we start at the 0. 0 is the first line here, right? First line here. So when you count 8, you start from number 1 here. You count this as a 1. So we count from here. 1, 2, 3, 4, 5, 6, 7, 8. So now this is the 8th row. And 2, number 2 here, represent, you count because the first one gonna be 0 or the start number 1 on the end and the edge here is count to be the 0 row. Okay, then you will count this one as a first term. So 2 mean the second term. So this is a first term, second term. So the answer coefficient is mean this one. It means 28 is the answer. Okay, so then you can remember we solved this equation already. HC2, if you simplify by the previous lesson you learned, right, become 8 factorial. Over 8 minus 2 becomes 6 factorial, right? And time R, this is a formula, okay? So 2 factorial. So we have what? 8 factorial times 7 times 6. This is the last example we just finished. And we stop at 6 factorial because I want to cancel 6 factorial down here. And times 2 factorial. So this one cancel. So 2 factorial mean 2 times 1, right? So to cut here, you have 4 here. So 4 times 7 gonna be 28. You see that? We get, this one is a coefficient, binomial coefficient, which is represent on the 8th row. This 8th row of the second term. We count this one as a first and this a second term. Okay? Because the outside there is always 1. So we don't count, we start count from the second one here. So this is the answer. You can see this is the same. 28, and this one we have 28 right here. Okay, everyone understand? So that is the Pascal triangle. So see if now we're gonna go to see the relationship of this combination. So why this one become the odd, and another way, as just say another way from the Pascal triangle here. If we lie at the combination form, right? This one is always 1, correct? Because base the two x plus y, the whole thing power 0 is always 1. But now we do the first row 1 1 here. How we get 1 1 from the lesson from this one, correct? But another way we use a combination. How we start from the first row here, okay? The first row here. See this one first row. We gonna lie this one as C. Always start from 1 1 C 0. Okay, 1 C 0, and then 1 C 0. Next one gonna be 1 C 1. Correct. Okay. Then the second row here. This one second row. This one always start the second row, right? So you're gonna have 2 C 0 because second row. So you write down here, become 2 C 0. And next one, the middle term here, right? Gonna have 2 C 1. And the one here gonna be 2 C 2. And then you can use calculator. 2 C 0 is a 1 here. 2 C 1 is equal to 2. 2 C 2, 2 C 2 here equal to 1. Okay. So now next one, the third row, right? The x plus y power 3. This one you always start because third row, so you write down at 3 C 0. And this one gonna be 3 C 1. And the third, this term gonna be 3C2. And the last one here gonna be 3C3 in order, okay? So third law, this gonna be n, this one gonna be 3, 3, 3. And the bottom arc start from 0, 1, 2, 3. See that? Second law, right? Second law, 2, 2, 2. 0, 1, 2. The R bottom. Okay. Then the fourth law, you can write down. Now you know now how to write down, right? Fourth law gonna be start with n equal to 4, C, 0. That means this one. And 4 here equal to 4. Next one gonna be 4, C, 1. And 6 here gonna be 4, C, 2. And 4th here gonna be 4, C, 3. And the last one here gonna be 4, C, 4. And keep going. So you can observe the first at the end for each law. 1C0, 2C0, 3C0, 4C0, and fifth law gonna be 5C0. It's always equal to 1 here. 1, 1, 1, 1. And on the right here, or same thing become 1, 1, 1, 1, 1. Because what? 1C1 equal to 1, 2C2 is 1, 3C3 is 1, 4C4 is 1, and next fifth law gonna be 5C5 is 1 also. So when you count the term like this example, SC2, we will count 8. We start from here, the first law. We did not count from the 0 law. We count the first law here. This count start from here. Count 1, 2, 3, 4, 5, 6, 7, 8. And the 2 here, number 2 here, represent you count start from here. 1, 2. That's the answer. Okay. So if, for example, if I ask you find the coefficients, find the binomial coefficient of, just say 6C3. Okay. So how you leave 633 equal to what? Form the triangle here. And you can draw also, right? 6 mean the low 6. So you count from this one, okay? The first low. So you count 1, 2, 3, 4, 5, 6. So in this low. And the 3 terms, so you count from here, okay? Not count from here. Count from here, first one. So 1, 2, 3. So the answer should be equal to 20. The binomial coefficient of 6C3. So you can check the answer equal 20 is right or wrong. Then use the formula combination formulas. 6C3, you have what? 6 factorial. Over to 6 minus 3 become 3 factorial. Times 3 factorial. So equal to 6 factorial. You can expand here. 6 times 5 times 4 times 4 times 3 factorial. So times 3 factorial down here. So 3 factorial cut. So 3 factorial means 3 times 2, right? So you're gonna have 6 times 5 times 4, right? 6 times 5 times 4 over 3 factorial means 3 times 2. So 2 times 2, 3 to 6. So cut here. So you have 5 times 4 equal to 20. Now you see answer same, right? Equal to 20. Equal to 20 here. This position means 6C3, the coefficient of 633. So in algebra, when talk about the binomial coefficients, we use like a previous lesson, we learn the combination. That's the one idea. That's the meaning part of that. Instead, you're gonna do like a selection, arrange how many way can be. Remember the last lessons? And after this one binomial, you will learn probability with it that is gonna use combination also. Okay, now try to get the idea. This go apply to many topics. And in this algebra, you help us to find the coefficient when for the binomial when the index, right, like when x plus y power n become very high number, high index. So we can use this one. But Pascal, we can use like this. You can rearrange for up to 10 maximum like this. But if power very high, for example, like a 75, power 75, how to do? We're gonna have formula later. Okay, that's another way. Even we can find and can find specific term between 70 x plus y power 75. Okay, we can find the specific term. But now this idea Pascal is really nice. Pascal is a one mathematician from, it's a French French, I think they find out this way. It's really genius, right? Okay, this is so nice to learn and have fun. Okay, so and then we're gonna go for another one more example, and gonna be that's all, and they're gonna let you do example. Any more for this one? Okay, so now we go next page for the next example. Use this one should be cut off here. Use the seventh law, the position at the seventh law of Pascal triangle to find the binomial. Binomial should be MIA swap, okay? Binomial coefficients. So question give this one. Find the seventh law of the Pascal triangle. So question can lie in this way, correct? Lie in this pattern HCO, right? Or you can lie in this pattern SCO. Or sometimes even though you can write it down like this, right? I mean not O, zero, and S0 like this, and this S1. Depend, right? You can write different way, but the same meaning. Now how we gonna find? Use the seven law of Pascal triangle to find the binomial coefficients. See this one, H. Come back to the previous lesson. You see, if the second law, right here, right? So we can use combination. We like this one, 2C0, 2C1, 2C2. So we know this is a second law. Okay, and if third law gonna be 3C0, 3C1, 3C2, 3C3, and fourth law gonna be 4C0, 4C1, 4C2, 4C3, 4C4. So come back to this question. They start from here. They load it down SC0, SC1, H, where N is H, and then 0, 1, 2, 3, 4. So you can see the first one here. We know like the way this one, we know this is a H law, correct? This is gonna be the H law. So how we gonna use 7 law? How we gonna use 7 law? 7 law, so how you use a calculator here. SC1 equal to what? Use calculator. SC1 is equal to 1, right? SC1 equal to 1. And SC1, HC1 is H, right? You use calculator, okay? Or you do by simplify, it's okay. And HC2 is 27, 28, I think should be 28. And HC3 equal to, become 8 fact over 8 minus 3, 5 fact times 3 factorial. HC3, you can use calculator, maybe faster because of timing. So this is 28, right? So I use calculator. HC3 gonna be 56, right? And HC4 70, right? Use calculator, okay? When during you waiting for me, you can use calculator also. HC5 is a 56. S AC6 is 28, right? SC7 is 8, and SCH is 1. H, CH is 1. Okay, now how we use this is the H low, so we have to use the 7 low, right? 7 low. So the 7 low, I write down here. I use another color, I think. Become green here. So how we gonna use the S8 7 low? Okay, 7 low here. I write down 7 low here. How we gonna use 7 low? So from the Pascal triangle, you remember it's a form period plus to the next low, right? So then you do opposite. Then you do opposite. For and the each low we're gonna start with 1, correct? Start with 1, right? Remember, come back here. This one we start with 1 1 1 1 1 here, right? And then we end with a 1 1 1 1 1 here. So then right now you observe right now this one is the H low, right? The one we have N here. This is the H low. Then we have to get the 7. How to get 7 low? To get the coefficient, binomial coefficients, right, of the 7 low. So this one have to be the 1H we have already. So the top one have to be 1 here. So come back to the question. This is gonna be 1. So this one gonna be 1. Okay. So 1, and the next one gonna be should be this one minus we work backward, right? So 8 minus 1. This one gonna be 7. Okay. This 1 1 1 1 here, and then 8 minus 1 we have 7 here. Okay. And then this is 28, right? This one 28. 28 minus 7, what we have? 28 minus 7, we got 21. And then 56 minus 21 become what? 56 minus 21 gonna be left 5, right? 5, 3. Okay. And then 70 minus 35. 70 minus 31, 35 gonna be 5, 4 become 35. And then from here 56 minus 35, what we have? Become 1, become 2. Okay. So then this 28 minus 21, you got 7. And 8 minus 7, you got 1. And from 1 to the last is still 1. Okay. So now this is a 1. Okay. This is a 1. Line here. So 8 minus 7 here, we got 1. And then we have the last term here, 1. So now we use the 7 law, right, of Pascal triangle to find the binomial coefficient. So we get now the answer of 7 law is 1, 7, 21, 35, 35, 21, 7, and 1. Okay, so you can see 1, 7, 21. We check from the period 1, 71, 35, 35. Check from the period the low 7, 1, 7, 21, 35, 35, 21, 71. Exact same. See that? Okay, now this is the Pascal triangle. But Pascal triangle is have fun. You can have time, you just pay the number like this. Very nice. But when the binomial two term with the index, very high index number or power, high power number, we have to use the formula expansion. So that's we're gonna do next class, okay? But then for this right now, binomial, what the meaning? Mean like for the combination formula before you learn the last lesson in algebra right now here means find the coefficients of each term and tell us to find uh, by using the Pascal triangle. Okay, so I think we can stop right here today, and then you're gonna have some questions for practice. Uh, if you have any question, just ask me in the GC or in the line. Okay, for group line or individual is okay. Okay, so you take a look one more time. Okay, so I think that's all for today for this lesson. Okay, see you next class. Thank you. Bye bye.